And welcome to the second video on how to calculate uncertainty when we're working with powers. If you haven't seen the previous video, please watch that because it explains how we find the uncertainty of the area of a circle, and it also explains the difference between absolute uncertainty and percentage uncertainty. So we're working off this document here. Where's it from? It's from your practical booklet in AQA. And last year, as we said, a question came up and it was asking you to calculate the uncertainty for an area. Caught a lot of students out, we hadn't really looked at it. And now we know, of course, when you're calculating the uncertainty for an area, you calculate the uncertainty for one line and you add it to the uncertainty for the other line. You don't multiply them. In this case, when we're working out the volume of a sphere, we've got powers, for example, like this, all we do is we bring that C down. So the percentage of uncertainty for area or for volume, we're going to take that power down and it's going to be C times the percentage uncertainty for B. So what does that actually mean? Well, remembering when we're working out the volume of a sphere, then what we're doing is we're saying the volume is equal to 4 over 3 pi r cubed. Now we have no uncertainty for this, we have no uncertainty for this, so all we're working with is this here. So our percentage uncertainty for the volume is equal to 3 times the percentage uncertainty for the radius. Why? Because that's what that tells us there, and we know that's our radius because we would take it from there. So let's continue to work with the same example. Let's imagine that our radius is 6 centimetres. In the previous video, we found out that the absolute uncertainty for a 6 centimetre line was plus or minus 0.1 of a centimetre, because we had 0.05 of a centimetre at one end and 0.05 of a centimetre on the other end. To then change that into a percentage, in other words, how does that uncertainty relate to the length of just that line, which is 6 centimetres? We said we needed to go 0.1 of a centimetre divided by 6 centimetres. It gave us 1.67%. So our uncertainty for the length of the 6 centimetre radius is 1.67. So how do we apply that now to the volume of the sphere? Well, all we do is we take that power down and we multiply it. So the percentage uncertainty for our volume is equal to 3 times 1.67. So our uncertainty, we haven't even had to calculate the volume of the sphere because we can work it out from this equation here. Our percentage uncertainty for the volume of the sphere is 5.01%. Now the question is, how do we then change that into the volume of uncertainty? We saw that in the last video when we looked at the area. You've got percentage uncertainty for the area, or you've got the area of uncertainty. So I would say this is a more appropriate figure to work with. Absolute uncertainty doesn't really tell us the impact on what we're measuring, because the absolute uncertainty is whether it's this big or this big, whereas the percentage gives us more of an idea. So at this point we actually need to calculate the volume of the sphere to turn it into absolute uncertainty. So I'm going to go
4 over 3 times pi times 6 cubed.
So now projecting that back to a volume, I'm going to say 5.01 divided by 100 times by 905 centimetres cubed. And so our absolute uncertainty, our volume of uncertainty for that sphere is now 45.3 centimetres cubed. And of course, working that backwards, we can see it actually works. Because checking that backwards, we can see that it actually works, because 45.3 as a percentage of 905 is about 5.01. Now, that brings an important point. When I say about, remember not to round too early when you're doing your calculations. If you start rounding from a very early stage, your end answer is just too far out. And here we have a question so that you can practice working out the percentage uncertainty and the absolute uncertainty for a sphere. Shout out for Ariba, who's one of my year 13 students. She's asked me to tell you that she's my favourite. But anyway, she made this question so that we could test our knowledge on the volume of a sphere. So I'll give you a moment to work it out, stop the video, have a go, and I'll post the answer in a couple of seconds. As you can see from the first step, we've calculated the percentage uncertainty for the radius. Then what we've done is we've multiplied the percentage uncertainty by the power of the radius, which was 3 in this case. Well done to Ariba for pulling that question together.